In our ISN, we're going to do some of the 1-4 notes. I'm not going to complete all of it today, but after that, we're going to go back and look into the 1.1 to 1.3 packet to do some review for our quiz tomorrow. We haven't talked about angles at all yet. Right, so we're going to talk about parts and kinds of angles. To name an angle, you use 3 points, one on each ray, with the vertex in the middle. Okay, so for example, I'm going to label this particular diagram that I made for you with 3 points, and I need one on each ray. But we haven't defined what a ray is. So let's do that right now. A ray is part of a line extending in one direction, wherever. So when they have the arrows on them, it means that it keeps on going, but you just can't see that. Okay. So let's go ahead and name this. I don't want you thinking that everything else always has to be in alphabetical order when you name it. So I'm going to call this angle B. So I'm putting a point on the top ray. That's B. And then I'm at the vertex. I'm going to put an A. And I'm going to put a C over here on the other ray. So if I were to name this, this would be called angle BAC. BAC. A must be in the middle. What would be another okay way to name the same angle? Murphy? Okay, CAB. So angle CAB is another way. There is one more, and that is only because this angle is all by itself over here. If it's all by itself, you can name it, okay, A. Yep, you can name it angle A. But if there were other rays coming off of here, then you could not call an angle A. Could not call it A. The vertex is point A. Okay? And in your like little terms, sometimes students say they call it the corner point, if you will. Although your book would not say that. The sides of a ray are the rays. Okay? The sides are 2 rays. So there are 2 answers when you're naming the sides of an angle. This side, that is a side of the angle. And that is side ray AB. So ray AB is one of the sides. It has to be AB. And the arrow has to point to the right when you name a ray. There's another side, of course, because that's only part of that angle. So an angle is an opening between 2 rays. This angle is opening. That's its opening, which could be considered anything in here. This is the opening of the ray. This is the other ray that makes the angle, which it is a side then of the angle, and it's called ray AC. Okay, so those 2 are the sides of the angle. Okay, now we're going to talk about, and I'm going to use highlighters. You would like to have 2 colors if you're highlighting. I'm going to talk about where's the interior. What do you think the interior might be of the angle? Here or here? So interior is on the inside, exterior is on the outside. So what we want to think of is this is the interior of this angle, which technically keeps on going. Okay. That's as far as I'm going to draw it on my paper. So I'm going to write the word interior on here. So the interior are points or area inside, which inside could mean between the rays. Okay. So if you think of between, the angle is actually what's the measurement between the rays. I don't know why I wrote or. It should say on. I didn't finish my N there. It says points on. Oh, that totally made no sense whatsoever. May I fix that, please? I meant to write points, and I did mean to write or because I said area, and I forgot the A on area. Points or area inside. Sorry about that. So if that's in between the rays, then the exterior would be everything out here. I got a really fat highlighter. Okay, so all of these points are outside of those rays. So this is the exterior, and this is also exterior. So exterior are points or area outside the rays. You want to put an arrow, that's exterior on this, and this was the interior. All right, so that's all we're going to do on that picture. Okay, did anybody still need that? Okay. Cool. Okay, thank you. Is everybody else good? All right, so now we're going to define acute. I bet some of you know some of these. Does anybody know what an acute angle is? Okay, so Kenny and Murphy and what? Wait a minute. I'm going to get something. It's Olivia. Your hair's not down today. I put it so. Less than 90 degrees. So it's between 0 and 90. So I have a way to write that. So good job. Acute is an angle that is between 0 degrees and 90. So the angles measure, which I use an M to, that means measure. So the measure of the angle is between 0 and 90. And those are less than symbols. That says M is bigger than 0 degrees, but less than 90 degrees. Let's draw one. I'm just going to make a V, if you will, which is composed of two rays. Okay, and I'm going to label this one with a T on the first ray, an I at the vertex, and a P on the right ray. So I'm naming it angle tip or pit. It's pointy, isn't it? It's kind of skinny, like the tip of your pencil. I like to mess around, so. All right, right angle, exactly. All right, exactly 90 degrees. And I'm going to get this protractor out of the way here for a minute. Whoops. Get it rid of Okay, so let's draw one that is a right angle. Need your little rays. And I'm going to call this one B on the first right, O at the vertex, X on the right side. This would be called angle B box. I don't know how to say XOB. But say the letters. All right. So, what? I didn't draw that perfectly, and you probably didn't either. So, yeah, you're perfect. What do you want to do to make sure you mean 90 degrees? Oh, that's why I called it box. All right, yep, we put the little square box in the corner there. At the vertex. All right, obtuse now. Obtuse, you might think, well, these are cute little angles. Obtuse is between 90 degrees and 180. Chubby angles. They're big. Obese. I know that's where some kids try to remember it that way. So let's call this one C-O-W. This one's angle cow. Oh, I just playing around. I wrote kind of close to my little protractor. Oh well. Okay, straight. Straight angle. Really boring. Oh wait. I don't like my line. I'm going to define it first. It's exactly 180 degrees. Yep. You will use the concept of a straight angle so much this year, you will get sick of it. Okay, straight angle. So I got to use my tool to make my beautiful line. All right, and I'm going to put some arrows on the end. The problem is I can't name it until I put some points in it, and I need 3. So, I don't know. Anybody got a name for it? Owl? Okay. O-W-L. This would be angle owl. It can't be written low. No. Why not? The W's in the middle. It has to be the letter in the middle. So it doesn't always spell anything. I just was goofing around making some words today, okay? So they're not always going to spell anything. Last time it was just going to be ABC, you know, or DFE or OPQ or who knows. All right. This is a super important concept. Let's look at this protractor type of thing first. You probably should be getting one. This is something that you're supposed to have for geometry. This one is not the best because it doesn't have measurement in the bottom. So you want to get one that's clear, like see how this is clear? That's why we can see through it and we can measure stuff in the picture. If you buy a solid colored protractor, you will not be able to see through it and it'll be a pain in your butt. So if you get one, and you do sell them in the IMC, they're cheap. It's just a piece of plastic. They should have measurement at the bottom. There should be millimeters and centimeters and then inches at the bottom. But this one, the reason I'm showing it to you is because we want to label our little fake protractor over here. And I want you to notice where the numbers are. Okay, lots of kids do not know how to read these. Okay, we're going to learn how to read them. If you already do, great. I just need to explain it. If you are pointing your ray this way, where 0 is on the outside. So there's 0. And then the numbers climb. 10, 20, 30, 40, 50, 60, 70, 80, 90. And then it goes all the way around on the outside till you get to 180. Now, If you line your ray up going to the right side, though, then 0 is not on the outside, it's on the inside, okay? So you would measure, oops, going, come here. I don't know what that is. I've never seen this before. That's cool. Oh, I'm finding some. Oh, look at that. I've never seen this before. Okay, so this is when I'd be measuring. I would be reading the inside numbers. See? Oh my God, this is great. Okay, you see how it's going from 0, 10, 20, 30, 40, 50, 60. There's your 90. And then these are the obtuse ones getting bigger, and I'm still reading the inside numbers. Okay, just discovered something I have not used before, obviously. Okay, I get excited over small things, I know. Okay, so over on the protractor, what I want you to note is 0 is on the outside when you're reading it this way. Okay. And then that's because you have your ray lined up going in this direction. So I am using two colors on purpose. I'm using one color right now because I'm talking about this obtuse angle right there. So if I'm reading that one, I'm reading outside numbers. And now I'm going to change colors. Where was 180 on this? If 0 is on the left outside, then the 180 was on the right outside. Okay, now I'm going to change and I'm going to go on the inside. So let's say your ray pointed in this direction. That's not a very, is that bright enough? Okay. All right, then your opening is going this way, and you're going to read the inside numbers. Okay, so now I'm looking at this angle. Do you see I've changed completely? I have a different angle right over here, and it's cute. And so 0 would be in the inside, and then I would read to wherever it landed on the inside. Okay, so it's just depending on which way your arrow on the bottom is pointing. And what goes right here? Do you guys know? What do you line up right there? What's it called on the angle? Yep, the vertex. The vertex goes there. Okay. All right, a little bit more, and then we're going to stop. Is this what we're going to finish up? Is this angle bisector concept? An angle bisector is a ray that cuts the angle in half. If it cuts the angle in half, it creates two congruent angles. I will abbreviate the word 2 with a number, the word congruent with the congruent symbol, and the angle word with angle, apostrophe S, would mean angles. Okay, I want to get rid of this thing. Oh, wait, I think I can actually turn the page, and this will be at the top. I'll rewrite this, so don't worry if you didn't just get that. So it creates, it was two congruent angles. Okay, I was going to be boring and use W, X, Y, Z's and stuff, but I think I'll do something else. Let's call this angle rat. The big angle. You see how that's the whole thing? Whoa. I don't need to highlight that. Okay, this is angle rat, and then I'll put in the middle P. Okay, so I'm going to make a statement. I'm going to also show you where this opening is. So I'm going to grab a highlighter. And I want to have you understand that this would mean I'm talking about the whole angle. Angles are openings. Talking about that whole angle when I do that. And I'm going to say that this angle is 70. Okay, I don't like that thing. So if that angle is 70 degrees, and I say that ray AP is the angle bisector of angle RAT. So if AP is the angle bisector of RAT, put an if in front of that, then what would be true? What could somebody tell me what would be true? If ray AP is the angle bisector of angle RAT, what would we be able to say? Okay, Carolyn? Good job. Then our angle RAP, angle RAP, is congruent to angle PAT, PAT, or TAP. You notice every way you go, you spell a word. Tar, tap, pat, par, rap. Oh, well, that was just for fun. Okay, now, what are they equal? They are both how big? 35 degrees. How do we get that? And now I want you to go over here, please, and mark the diagram with a double arc here and a double arc there, meaning that these angles are congruent, and it could have been a single arc. I just chose to do a double for something different. That's 35 degrees, and this would have to be 35 degrees as well. Okay? All right, that's all we're going to do on this today. We'll come to this part on Friday. So let's pop over to our 1-3, 1-1 to 1-3 applications, please. Why this? Yep. We will be doing a little warm up before we do our quiz tomorrow. Okay, in the application packet, 1-1 to 1-3. We talked about some of these already, didn't we? What page did we get through? And what number did that end with? No, we did that. Oh, we didn't? Okay, thank you. Let's do number 9. I did that with my other classes today, so we actually were ahead of everybody else yesterday. Good job. Okay, let's draw a picture for the situation because that just usually helps in this class. We got the Perez family driving from Austin, Texas to Dallas, Texas. We're going to assume it's a straight line. Okay, so if we're going from Austin to Dallas, Austin would be where you began and Dallas would be where you ended. And then it says the city of Waco is the approximate midpoint, which would mean it's where? Right in between A and B in the middle. Okay, so that would mean that I'll just use W for Waco so we can keep remembering what they stand for by the first letters. Okay. Were you gone yesterday? They're right there. I put your papers when you're absent in the 7th period folder for this class. Okay. What's the total distance from Austin to Dallas? Well, wait a second. We got to finish reading here. It says that it is 102 miles from Austin to Waco. So that would be right here. And since we already said that W's in the middle, the Waco's in the middle, then that would make these equal. So we can put a 102 here, right? What's the total distance from Austin to Dallas? All right, 204 miles. Okay, next. The approximate midpoint from Waco to Dallas is Milford. So, oh, I already put that little slash almost in the middle, but okay. This is going to be Milford now. If it's in the middle, that makes WM equals MD. If it's in between Waco and Dallas, midway, then it would cut that in half. Agreed? All right, now I use double hash marks to indicate that that's different than these other two. So if that got cut in half, how big are each of these? 51. Good job. Okay. So what's the distance it says from Austin to Milford? So we want to go from here to Milford. Boom. So that's going to be the 102 plus, and you're right, 153. Yes, Kayla. It's 51 miles more after you get to Waco to get to Milford. So 102 plus 51 is 153 miles. The next part says the Perez family averages 64 miles an hour. How long did the entire drive take? So they were going pretty fast if they stopped, anyway, because they averaged 64 miles an hour. So how far did they go, though? So we got to think about all these things we thought about. What was the total distance they traveled? Yeah, it was the 204. So we take the 204 and we divide it by 64. And that should give us the number of hours. It's like 3.1, if I remember correctly, 8, blah, blah, blah. Okay, so let's go to the nearest tenth. So it'd be about 3.2 miles. Approximately 3.2, not miles, but hours. Right? So a word problem would be a good question for the quiz involving the segments and subtracting and dividing by 2, etc. Oops, I forgot. I've got further than that. This is just another segment one that's kind of similar to that. So I'd kind of like you to just do some of these on your own, and then I can maybe answer a few before we do our quiz tomorrow. So I want to get to something else. I do want to point out that the distance is the amount of space between 2 points in a number line. You might have been able to fill that in on your own. It is always expressed as a non-negative number. That's 13. So I'm asking you to still do 12. Also, this is another number line one, helping you figure out where things are. So I'm going to skip that one for right now. This is another segment one, and we already went over that. You understand that you are just simply finding the ones with the same hash marks and saying that they're equal. Okay, this one I wanted to talk about. Number 16, please. So it says the temperature on a thermometer dropped from a reading of 25 degrees to -8 degrees. Find the midpoint. Midpoint is when you average the coordinates. So if you think about a thermometer, if that was 25 degrees and this was -8 degrees, we're trying to find the middle. So how we do that is we add the numbers and divide by 2. 25 plus negative. We'll have to do this on your quiz tomorrow. Okay, so you're going to need to know how to find the midpoint, the given 2 points on a number line. This is 17 divided by 2. And then half of 17, you can go ahead and use a decimal, would be 8.5 degrees. Not always going to be a whole number. Does anybody need this? Okay. I forgot I had one that was the key, actually. So in this figure, let's see, do we need to do this one? This is another finding the measurement of a segment. So let me skip to something different. I wanted to look here. This box is really hard for students to look at. It's a 3D drawing on a 2D piece of paper. So I'm curious. How many of you see this as a back wall and this is hollow? Okay. How many of you see this as, I'm noticing somebody, I saw a little bit of hands. How many of you see this as the front of a box? Okay. That's their intention. However, I'll give you how you can see what I was saying in the first place. Now where's the H? The back, isn't it? Isn't that weird? It's strange. Like, yeah, it's like the depth perception changed. Bryce, do you have a question? Oh, you're just judging. Okay, so let's just look at it. We don't need to know that. I just had to show you that visual trick, right? Okay. Get rid of it. Oops, now I'm back to it. All right, point H lies in planes AGE, and I'm going to use a highlighter. AGE would be the back. What I need you guys to remember is that when you are talking about, they only give you 3 points for your plane. You need to continue coloring in the whole flat surface. You have to think of the entire flat surface. Okay. Then it says point H lies, and does it lie in GED as well? Well, that's the bottom, right? So H is in there no matter how we think of this picture. So that would be true. So let's say the question was all just true and false. You would answer this as true. Next, planes GAB, GFD, and BED intersect at point E. So I'm going to highlight the one that I don't have highlighted yet. BED, which is over here. Okay, do these 3 walls, if you will, meet at one little point? Now, you're going to think I'm contradicting something I've said over and over in class. I have told you continuously that 2 planes intersect in an entire line. But where does the ceiling, the wall over there, and this wall meet? Up in that corner, right? Just that one dot. So that's when the answer can be a point, is when you have 3 planes. It's like the corner of the box. So it's, they do intersect at point E. So that's true. All right, next. Points F, E, and B are coplanar. Well, F, E, and B, coplanar. Well, any 3 points are coplanar. Now I can show you why with this box. F, E, and B, coplanar. Can I make a plane that those are in? Yep, it just chops it in half. I know, I made it look even weirder. Okay, so yes, you can make a plane that connects any 3 points. This is always true. If they give you 3 letters, 3 points will always be coplanar. Now, are A, H, and D collinear? A, go to H, go to D. That's on the back right there. Okay, or the front, because I messed you all up in the head. This one's popping off of it, so this is false. So the one that was not true was D. You need to understand all of them, but when to read them and figure out which one is not true. Okay, look at a couple of these. This is something that We will have a picture similar to on the quiz. What are the two other names for line AB? So line AB would be, you can't use one point to name it, but you were right, because M is not a point. So you are totally correct. Your line M is fine because M is not a point and it's italicized. So you have to use the word line though if you're going to use that thing. I need another way. BA. Okay, just flip the letters. All right. I need another name for plane P. So now they already used up the non-point way to name it. If you're going to name this plane, there is a way up here that you cannot do it. It can be plane C, B. Can you do F? You can't do F. C, B, and F are all in one line. It can't be collinear. But you can do C, B, and D. No, A is not on it. A is underneath. Maybe I should erase it at this part right there. See? It's like sticking through it. Name the intersection of plane P and line AB. Now line AB is line M. It goes through the plane and whacks it at point B. And name three collinear points. They have to be on one straight line. That would be C, B, and F. Okay, these kinds of questions will be on the quiz. I think I went over this one. Did I? Oh, no, I didn't. Did I? Oh, I didn't see it. Whoopsie. I scribbled all over there. Name 2 points that are not, I scribbled it out because how the heck can you name any points that aren't coplanar? You can't do it. Can't you make a plane through any 2 points? A flat surface hit 2 points? You can make a line through any 2 points. I have no idea where that question came from. You can always make a plane through 2 points, and you can always make a plane through 3 points. So this was a terrible question, shouldn't be here. I would never ask you that. Cross it off. This would be the distance formula. You can make a right triangle on here. These are just humongous numbers. This number, the 23,525, would be right at the bottom because it's the X number. And then the vertical number would be the 12,633. So you'd have to do this 2,300 and, oh my gosh. What? Oh, that's not even right. This was the 9,3. I got to subtract these. My bad. I just paid attention. Okay, so this number is actually not the 23. Hold on. This you see, okay, you know how a mountain is not necessarily at sea level? Okay? The mountain is maybe 12,633 feet above sea level. However, the base of it is already at 9,300 feet. We would actually have to take the 12,633 and subtract 9,300. So we could get this number right here. What would that be? 3, 3, 3, and 3. Oh my gosh, right? Bunch of 3s. So now we can do the Pythagorean theorem and take the square root. So the distance formula would give me, and here's the easiest way to do this formula. I already found out the difference in the x's and y's, so I'm going to go 23,525 squared plus 3,333 squared. Okay, and these are in feet. And I would have to do this in the calculator. I don't want to waste a bunch of time on that, but that is what you would need to finish doing. And then you would have to convert it to miles, but I can show you that later. One real important thing, 25, before we go, because I want to remind you of something from 1.2, is the betweenness thing. If it says B is between points A and C, where does it have to be? And does it have to be in the middle? It does not have to be in the middle. If you know AB and BC, you take AB plus BC to get AC. That's what they were asking for. Please do some more of this packet if you have not looked at all the problems and know which ones you'd like some assistance with before we quiz and we do a little warm-up. Grades will be in the grade book. Oh, they already are. Anybody look? Okay, there were 4 categories and they're out of 5 for each section. You should know which one you need to study from. Study for.